decomposition of functions and inverses as well. Okay? It is some similarities of what we did in the past. Okay, I'm going to start by something we did yesterday first. Okay, so I'm going to start with a function f of x. Okay, with that being the case, let's say that is 3x squared minus 4x plus 2. Okay? I would like to start by saying, please find f of negative 3. How are we going to find f of negative 3? We learned this yesterday. Something very simple, correct? Spy, what do you think we're going to do? Wherever we see the x, we're going to put in negative 3, right? So therefore I have 3, negative 3 squared minus 4 times negative 3 plus 2, correct? Okay, so this is what we're trying to find. This equals order of operations. What am I going to do next? Kind sir, what's your name again? Right here in front. Jake, what are we going to do next? Order of operations tells us to do what, bud? Okay, what's inside parentheses? Anything to really do inside the parentheses? So what's the next thing we're going to do? Okay, do we have an exponent? So what is our exponent? Negative 3 squared is? Positive what? Awesome. So we have 3 times 9 minus 4 times negative 3 plus 2, which then comes to 27 plus 12 plus 2, which comes out to be 21. Correct? Are we all fairly decent with that? Maybe struggle with that out. Now, what if I ask you to find f of negative 2n? David, what are we going to do? Okay, so therefore we're going to do 3 times negative 2n squared minus 4 times negative 2n plus 2, correct? Does everybody understand where that came about? Any questions? Still using that same f of x, right? Okay. What is negative 2n squared? Bailey, what do you think? I believe it's 4n squared. So I'm at 3 times 4n squared minus 4 times negative 2n plus 2. Then I get 12n squared plus 8n plus 2. And I can't simplify that anymore, can I? Make sense? Any questions? Okay, pretty simple, huh? You okay, Parker? Yeah. All right, brother. Then, okay, here we're going to go ahead and do f of n plus 2. So, what's your first name? Something, huh? Taylor? Okay, what are we going to do here? Yep, you're right. For every time we see n, x, right? Okay, so this is 3 times n plus 2 squared minus 4 times n plus 2 plus 2, correct? Noticing the key thing here is what? Every time we insert something, it's important to have parentheses, right? Hey, are you done? Yeah. driver's ed, did you? Oh, it's all right. It happened. That was my fault. Okay, so then we're going to simplify. Okay, when we simplify, notice this 3 is still going to be here, just like we did in the past. Anybody know what n plus 2 quantity squared is? Yes, sir. N squared plus 4n plus 4, because this guy over here is n plus 2 times n plus 2, correct? And after we FOIL this, this becomes 3n squared plus 4n plus 2 equals 2. Did I lose you? What did I even do? All I did was multiply n by n, I get n squared. N times 2 is 2n. N times 2 is 2n, so how many n's do I have? 4n. 2 times 2 is 4. Okay? Remember, do not distribute just the 2 through, the squared through, right? You've got to understand this is a binomial times a binomial. Okay? And then last but not least, we just kind of distribute our numbers through. 3n squared plus 12n plus 12 minus 4n minus 8 plus 2. Remember to distribute that negative 4 to both people, right, Marta? Okay? Are we done there? We need to combine like terms, correct? Okay. 3n squared plus 8n plus 6. And there it is. Okay? Now, that was a lot of review what we did last time, correct? We did this last time in yesterday's class or 2 times ago. Right? Okay? So now, what we're going to do is the composition. So I'm going to write, let's just even start here. Okay? Let's have these 2 lovely equations that we already have. Actually, I'm going to write them. Okay, so I have these 2 equations. Does everybody see that? You okay? What we're going to do is, remember how I told you yesterday why I don't like using this circle for multiplication? We had that fog, remember? With that little O in between it? You remember how when we multiply over here, sometimes, like instead of seeing this asterisk right here, partner, there's some people that use a closed circle, right? And the reason why I don't like that is because the thing that we're going to do is called composition today. And what I want you to do is look for maybe HOG. Hog. Okay? But what does this mean? It does not. That is why I don't use the times thing over there. Okay? This is not. Because see how that's not a filled-in circle? It means composition. What this technically means is H of G of X. H of G of X. That's how you would read that.
Wait, so on that one you would put H on the outside and then G on the inside.
We're not multiplying. I'm going to show you what we're going to do right now. We're going to take what we call composition. So, just like yesterday, whenever I saw a function, then I would replace it with what I have, correct? Does that make sense? Like after number 1, I would separate that to be G of n plus H of n, correct? And I would substitute in for those functions, right? Everybody understand that? Okay? Alright, so with that being said, what can we substitute in? Well, I know what g of x is, don't I? What is it? 2x squared plus 3x. Now doesn't this look like what we've done in the past few examples? Well, it's not multiplying. Not multiplying. Okay, sorry. I'm really trying to hit that because some people think that, right? But it's not multiplying. What's happening? Notice the x is being replaced by this new function, correct? So therefore, in this x, what am I going to put? The new function. G of x is this stuff, right? That's what it says. Okay. Exactly. Exactly. You said it exactly right. You're plugging the function g into h's function. That's what a composition is. Really, you can use this. Like, for example, you get how many miles per gallon, right? And then let's say how many, okay, so like my truck, it gets 12 miles per gallon. It holds 35 gallons per fill-up. So how many miles can I get per fill-up? You kind of use the word composition. It's two functions. It really is. That's like an example of how to use it. Okay? So, but this is nothing different. Does everybody understand? This is just what I'm telling you right now. This equals this. This is something you just needed to say, okay, Mr. Roberts, I get that. It's just what it is. Right? Is everybody okay with that? You just have to know this. Now, from here to here, what I did is I separated and said, okay, what is g of x? This equation. I just substituted like I've been doing, correct? But now, this is exactly what we just did on our last three examples. We are replacing x with what's in for it, correct? So therefore, this h of 2x squared plus 3x minus 4 is what? Can somebody help me out here? Savannah, can you help me out with that's going to be? So I'm going to replace this x with this stuff. So how is it going to read? So I would go 4. Maybe I'll just do it and then maybe I'll let you guys look at it. 4, 2x squared plus 3x minus 4 minus 8. Now take a look at it for a minute. Look what I did. Notice h of x. Notice my x is being replaced by this function. Correct? Exactly. Okay, take a deep breath. Clear your brain. Here we go. We just did it. Did you understand the stuff we were doing here? Be honest with me. Bingo? Did you understand? Okay, where did I lose you? Did you understand, first off, the key thing, did you understand inserting things into the previous variable x or n? That's the thing I want to make sure of. Then the arithmetic, maybe you had struggles with. Would that make correct sense? But do you understand the idea that x is being replaced by n plus 2, so therefore I'm inserting it n plus 2, right? Okay? Okay, so that's all I'm doing here. Notice h of g of x, h of g of x. Now, this is the same thing now as h of x, but instead of that x, I have this as my input, correct? Okay, where's the difference? Okay, from here to here, that's the same. I just wanted to do it down there. No, I'm just trying to make sure you guys are good to go. So now, I'm putting this stuff, because see how x is being replaced by this stuff. So therefore, that x right there is going to be replaced by this stuff. Right? So 4 times this stuff minus 8. So then I just distribute through and I get 8x squared plus 12x minus 16 minus 8, which is 8x squared plus 12x minus 24. That is h of g of That's half of your homework right there. Inverses.
So they're using leverage.
So a little bit. It's a little bit. I'll get to it. But we gotta obviously practice this a little bit more. Right? It's really not too mind-blowing. You guys just barely understood the idea of what we were doing previously. Now you just gotta add a little bit more and connect them. Right? Figure the connection. Okay. Now, I want you guys to do g of h. Of x. Using the same functions that we had up top. What was our function we had up top? G of x was 2x squared plus 3x minus 4, and then h of x is 4x minus 8. Right? Using those same functions. Now we're going to do g of h of x. So can somebody tell me what this looks like? H of x, close your big parenthesis, correct? Does everybody see that? You guys understand that's the rule that we're learning today. Okay? Yes or no? Okay? Now, this is equivalent to what? This is g of, what is h of x? Okay, you're okay. You're the one that's talking a lot. Are you okay? To there. Is everybody good to there? Not hard, huh? Oh, I substitute what h of x is in for it. Exactly, that's why I use substitution. Right? Okay, now, what does this equal? Well, doesn't this replace the x of g of x? So therefore, in the function of what g of x is, whenever I see an x, I'm going to replace it by 4x minus 8, correct? So therefore, it is 2 times 4x minus 8 squared plus 3 times, I see an x, so I put another one, right? 4x minus 8 minus 4. Yes or no, David? Just stretching? Okay. Do you understand though? You good? Gentlemen? All good? Right? Okay. Okay. I would appreciate that. Okay, so now this is the arithmetic part. This is just doing basic things that you've learned in the past, correct? So we're going to write this out. Isn't this equal to 2 times 4x minus 8 times 4x minus 8 plus 3 times 4x minus 8 minus 4? I just expanded that so you guys understand that we're going to have to FOIL this, right? Start kind of working on that. Okay? so now I'm going to start distributing through. I get 2 times, notice, 4, oh, actually, that 2 is out there. Oh, whoa, whoa, whoa. Actually, it's in between. You were right. Yeah, because that 2's out here, huh? Okay, so this is 16x squared minus 32x minus 32x plus 64 plus 12x minus 24 minus 4. But then I need to distribute that 2 through, don't I? Sorry about that. 32x squared. Notice this guy becomes negative 64x. So that, excuse me, that becomes negative 128x. Right? Plus 128 plus 12x minus 24 minus 4. Now, am I not saying this isn't long and tedious?
Wait, why did you divide the 64?
I didn't. I'm just telling you that these two equal negative 64x. Better? Because notice I distributing that 2. You okay with me now? By the way, good job over there. Sorry. Good job doing it. So now I'm at 32x squared, negative 128 plus 12 is a negative 116x. 128 minus 24 minus 4 is plus 100. Pretty cool, huh?
Wait, you distribute the 2 again?
I never distributed in the first place.
No, because you did it. Wait.
I never distributed it up here. Look, I only distributed it. Hence, advanced. This would be g of h of x. So now, what if I asked you guys, just in case, Caleb, what if I asked you guys to find g of h of 2? What would you do? Well, isn't this h of g of x? So therefore, you just replace these x's with what? I'm not going to go through that process, but I could. Okay? Does that make sense? What I was just doing? Okay, so this right here is the same thing as g of h of x, correct? Now what I just said was up here, I just so therefore I'm just replacing 2, and then because this is what that equals, instead of having to plug it in and doing the whole thing, I can just plug it right in. So therefore this would be 32 times 2 squared I could. That's the only reason why I want to do that. Okay, last one for composition. Okay, so using these same functions, okay, I want you to find h of x. You can push pause and like you guys can try this one right up here. So we're going to talk about this being, this is our equation. It is recording. I'm going to talk about it. So this is our equation. G of x equals square root of x plus 2 minus 3. Now, this is considered an output. This is considered an input. Another thing that we know that we're more comfortable with is that x is still our input, but instead of g of x being our output, y is our output. Are we okay? It just means the same thing. These mean outputs. Yes or no? What is the definition of inverse? What was my definition, not yours? The outputs are the inputs are the outputs. Or the x's become the y's, and the y's become the x's. The x's become the y's, so the x's become the y's. Oh, just whoa, 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 whoa. The x's become the y's, and the y's become the x's. Okay. 1 second. So, we don't want to solve for x, exactly. These are not the same anymore. One is an equation and one is its inverse. Now, like you said, we don't like things solved for x. So we want something equivalent to this inverse but solved for y.